The cases of the discriminant for the quadratic function. With respect to the formula for solving the quadratic function, we must know that we always have two solutions for the equation. This is the formula for the first solution, and this is the formula for the second solution, as we've seen. Of course, we must memorize both formulas. The results from these formulas we call the solutions or roots of the equation. As for the type of numbers that will result, this is determined by this value under the square root, and we call this value the discriminant because based on it, the type of the two resulting numbers is determined whether they are real or imaginary numbers, or rational or possibly irrational. This gives us four cases for the value under the square root. The first case is when the value equals 0. This simplifies the equation for us and gives us two equal solutions, and we say in this case that we have a repeated real root, meaning the resulting number is real and repeated. As we said, we must always have two solutions for any quadratic equation. The second case is when the discriminant is less than 0, meaning a negative number. We talked about negative numbers under the square root and said that it takes us into the world of imaginary numbers. This means the solution will be two complex roots, meaning they have an imaginary part and a real part, as we mentioned in the lesson on imaginary numbers. As for the third case, the discriminant is a perfect square. What's meant by a perfect square is that it's the square root of a whole number with no fractions, like 4, 9, and 25, for example. In this case, the two roots or solutions are two rational real numbers. We have the fourth and final case in which the discriminant is a positive number but not a perfect square. What's meant by not a perfect square is that its square root is a number with digits after the decimal point, for example, the square root of 3 or 5. In this case, the two results are two irrational real numbers.